Okay, hey everybody, this is a screencast to cover the list methods section of Unit 3. This is the last section of notes for Unit 3, and in your Unit Notes project, you'll see there's a starter file for list methods. So that's where you should go find that, make sure your main is importing correctly, and that should get us ready to go. All right, so in this section, we've already covered basic construction of lists, so you know what a list is, and you're aware that a list is a data structure that can hold any type of value. So you can store a list inside a list. You can store tuples, integers, floats, any type of value can be stored in a list. And lists are objects, right? The same way turtles are objects, and they have their own methods. And just a recollection, a method is an ability or behavior that an object has. So it's something that belongs to an object. It's something it can do, something, an action it can perform. So just like strings had methods, turtles have methods that allow them to have behavior. Lists are also capable of that and having their own abilities. We call these list methods, right? So, for example, today we're going to use a row of parked cars or just a row or line of cars as an example. So you can see we have a list here already initialized called row to represent our row of cars. And then in this row of cars, you have just string values representing a bunch of cars. So you can kind of visualize this as like a row of cars, you know, when you go to the grocery store and there's a parking lot and there's a whole row of cars, right? You can just visualize it that way. Or if you want to visualize it like on a highway, for example, cars one after the other, right? The idea is you've got a sequence, right, represented by these cars. All right, so if we print this out, in our output, we can see list has the feature of when you print them, you can see the actual list. So we can see this by just printing it out. Okay, so up to this point, the only way we know how to really make changes to our list is by using concatenation. So for example, just like tuples and strings, we can concatenate lists together as long as we have two of the same type. We can add to our list. Let's say we want to add a Ford and a Tesla to our list of cars. We can do that. So that by adding the two together, the initial list gets updated to add these two cars to it. But strictly speaking, we didn't actually change the row. And this is important to understand because we're going to talk about the mutability of lists, because lists are mutable. But concatenation doesn't actually achieve that, because concatenation, what happens is you take the second list and then you add it to the first list, right? And it produces a third list. So this, what is actually stored in this variable here is a brand new third list combining the existing two lists. So we never actually changed our original list here, even though this variable appears to show that effect, right? Now the benefit of lists is that they are mutable, whereas like tuples were not mutable. So tuples, this is the only way you can add items to a tuple would be to use concatenation. A list comes with all these nice methods that allow you to do this in a much more straightforward way. So the first one, I got another note here, so let's add this is. So we're going to talk about how list methods provide ways to mutate the list, whereas concatenation does not create a list. Right, so in order to mutate, we've got to run a method on our object. So the first one we're going to look at is called append here. And we're going to cover several of these. You can see the rest of these notes are basically me showing you how to just use all these various methods. Right? And this is just a sampling of all that's available. As with other types of objects that we're going to use, like turtles, there's documentation for this. So I have another tab pulled up here that has this documentation on all the various list methods you can use. So append, extend, insert, remove, pop. You can kind of scroll down and just see all the various types and some examples here as well for some of the methods that are available, right? So you can always use the documentation to find out exactly how to use it and what's available. One that's very commonly used is append, right? Because it's often that you have some list of things and you want to add to it. And the way you do that is to append. So we can take our row of cars and append items to it if we so choose. The append method can only take one item at a time. If we want to add another Ford to this row of cars, all we have to do is append it. Right? We don't have to do anything like this. With strings, we had to kind of like reassign because strings were not mutable. Right? This row is a list, and a list is mutable, so therefore this will change the actual list when we append to it. Right? So that's what the mutability feature adds to this. So now when we run this, it directly appends forward to our list. This list that you see in this line of code here, or in this output here, is actually changed and mutated to be now this list. Okay. Now appending more than one at a time is not possible. So the append method just takes one argument at a time. I tried to append multiple things. Right? It's going to tell me that append takes exactly one argument, and I gave it two. Right? So we can only add one thing at a time using this method. And we cannot do more than one. Right? This will error because append only accepts one argument at a time. Oh, and I guess that was kind of commented right here. You could have just commented that out and saw the same thing. Right, so that's that. Now, when you're a common use of this append would be to like accumulate information from like a user. So let's say you wrote a program where you've got to gather a bunch of information. You want to maybe do that with a while loop because over time you want to be able to accumulate every piece of information. And one way to do that would be to write a while loop, as just to show you an example, right? So like you could say, have the user specify a bunch of cars, right? And if the car was specified, so if they actually put a value in, then you can append it to your list of cars. And that would allow the user to keep going while they put a valid car, so while there is a car that's input. So we can enter a bunch of cars, right? Honda, Jeep, Toyota, then you leave it blank to exit. It exits. Oh, we didn't print though. So let's try it again. Honda, Jeep. Okay. Honda, Jeep, Toyota, leave it blank. and then you can append one at a time. All right, that's append. So as mentioned, the rest of these notes really just go and demonstrate a bunch of different methods. The second one is pop, so remove an element by index value from a list and return it. So if you want to turn this into a challenge, see if you can remove the first car in a row using this pop method. Pause the screencast, see if you can try it, and then I will show you how to do it. All right, solution would be by index value, right? So pop would just remove the first item if you pass it 0. So if we look at this, we run this code, you can see that Ford was the first car, pop removes the first car, and it's important to note that everything in this list will then shift in terms of index values, right? So the 0 index was Ford, and now Audi is the 0 index, and everything gets their index shifted by 1. Okay, remove method, see if you can figure out how to use this one. So remove, but now by element, so by specified element. In terms of element value. Okay, so see if you can try that, and then I'll show you how to use that. Okay, it asks you to remove BMW. That means you just literally say BMW. So if you want to remove a BMW from your list, what this will do is it will iterate through your list. It'll find the first occurrence of that value BMW if it exists, and it will remove it. Okay, so here we go. You can see that BMW was, at this point, the second item in our list. You look at the output on the bottom, and then after we run the remove method, the BMW gets removed, and again, everything else that was to the right of it gets shifted 1 to the left. Right? So that's a good way to remove. So it's important to differentiate between pop and so like pop is by index value, remove is by actual value. Right? And the other way to do a remove is using the del keyword, which is also using the index value. Right, sorting. All right, you can sort your cars in ascending order. Go ahead and try to run this method. There is no arguments to this method on your list and see what happens. Okay, so if you sort the row of cars, you might have been able to anticipate this, but the way it sorts is alphabetically. So at the bottom, the very last list we print is now an alphabetical sorting of the cars. So depending on what type of thing you sort, right, it's going to compare them all, and it's going to have a default way to order them. So for strings, you can obviously see it's an alphabetical sorting. For numbers, it's going to be numerically, right? It's going to sort it from 0 ascending. Reverse method can reverse the order of a list. Again, no arguments. Go ahead and try it and see what happens. Okay, so just like the other method, you're just going to call the method using dot notation here, right? And let's do it a couple times so we can really see the way it works. Okay, so if you do it, let's see on your output here that the first time you reverse, that alphabetical list we left off with ends up being reverse alphabetical order. So starting with Tesla, ending with Audi, and then you reverse it again, it just flips it again, right, into the opposite order. So not sorting it at all, it's just literally flipping the list around on itself. Okay, a few more. Count method is going to count the number of occurrences of an element. So if you want to count the number of Fords, see if you can run this method. you're going to want to print the result of this, because this one, it not only counts the number of elements of an element, will return it, right? So there's a return value here we need to pay attention to. So when we count forward, we're going to want to make sure we print it or save it and print it so that we can actually see what it is. So let's do that. And at this point it says 2. So there were 2 forwards. Yep, second item and third item are both forward. All right, so that's how count works. It can count up how many elements you have by value. Index can figure out what index value an element is. So let's say, for example, you wanted to find the index value of the Jeep, right? So see if you can run the index value to figure that out. Right, here's the example. Again, this returns. So it displays the index. It does not display, that should not say it. So it returns the index value of an element. So what will happen is from your row, it'll iterate through your row, searching for the first Lexus it encounters. In this case, returning and printing the value. Right? The prompt asks you to do Jeep. Let's do it with a Jeep. 3 is what resulted. And we can look at the latest list here, and we can count up that Audi 0, 1, 2, Jeep is our third 3 index value element. All right, finally, insert method. Let's say, so we're imagining a line of parked cars. Let's say, you want to insert a car in between 2 other cars. How would you do that? There's a method called insert that can achieve it. So see if you can insert a Harley Davidson through some trial and error, possibly, into the second parking spot. Go ahead and try it. All right, this one may have taken some testing or research to get this one correct, because this one is accepting 2 arguments. So it asked me to do Harley Davidson. I'll use that as my example. And if I want to put it in the second parking spot, the way this method works is it first accepts the position that you want to insert it. So if I want to sit it in the second spot is 1. All right, so let's see what happens when I insert Harley Davidson at index value 1. See what happens is the Harley Davidson gets inserted into the 1 index spot, right? And then everything, or the Ford that was in the 1 index gets shifted to the right. So when you insert, it does insert the element at the position, but then everything else, right, in this list gets shifted to the right. Okay, so your list grows by 1 if you're going to insert. Okay, now those are all the 8 methods that you need to know for this class. And we will move on to some practice with these next.